Okay, welcome to today's webinar from Appvia. And today's webinar is entitled, Why is Kubernetes So Complicated? And we're going to be exploring that. Before we get started, there's a couple of things to go over for housekeeping detail. As we talk through Kubernetes and its complexities, you're welcome to submit questions by clicking on the question tab on the right. We have also created a blog which touches on this same subject, and it's on our website, appvia.io. And lastly, there's a feedback tab on the session so that you could offer feedback as well. We'd love to hear from you. And with that, we'll get started. I suppose we can take down the slide and introduce ourselves. I'm Tennis Smith, and Salman.
Hi, my name is Salman Iqbal, and I'm a solutions engineer at Appvia. I have been working with Kubernetes for the last 3.5 years. I have run quite a few systems in production in Kubernetes. 3.5 years sounds quite short, but I feel like tennis in terms of Kubernetes is quite long.
It's a long time for Kubernetes.
And currently I'm working in Appvia as a solutions engineer, and I do work in the MLOps area, so just taking any of the machine learning workloads and running them in the cloud efficiently and at scale. So any of the cloud services, including Kubernetes, that's what I do. And I also do the training from within Appvia, so anything to do with cloud or Kubernetes or anything like that. And I do like, Tennis, how you coughed while pronunciating the title. That was very good, very apt.
It's a word that you can insert anything you like in that blank, which leads me to what we're going to talk about, which is the idea behind Kubernetes, why it got so complicated. How what I think is a simple idea that evolved into this technical behemoth, and we're going to talk about things like what contributes to its complexity and how it differs from a classic monolithic application strategy, and the trade-offs, of course, because it's a technical world. Nothing's free. Everything's got a price. And of course, the explosion of the configuration options. And finally, at the end, we'll get into, when your head is about to explode, we'll get into the mitigation of these complexities that we can talk about. So with that, I'll kick it off by saying that the idea behind Kubernetes is a very simple one, which is that let's build an ecosystem where you can have applications as simple as possible so that we can concentrate on building applications alone and not have to worry about a lot of the ancillary things that go into building an application in the classical monolithic model, which we're going to go into more, and how that simple idea has turned into a pretty complicated implementation. So I don't know if you wanted to there's the CNCF landscape we can show. That's a nice segue into what we're talking about.
Absolutely. I think, so I think I agree with what you're saying. By the way, apologies, I've got some work happening right next door, so you might be hearing somebody drilling in the walls, but I'm going to try and keep it so you don't really hear
ignore
that.
the jackhammers.
Yeah, ignore all of that jackhammer, drill machine, anything that might be happening. That's just coming from next door. So Tennis' point is very, very, very good point. The point is that we need to make sure our applications are quite simple, and we want to run them in the cloud in an efficient manner in cloud. And we talk about Kubernetes too. But when you need to run anything in cloud native way, as in like we can scale up when we need to, we can scale down when we need to, use cloud more efficiently than we can. There's a lot of options. And for example, you say, I want to run a database in the cloud. How do you pick to run a database in the cloud? And as you can see, one of the places you go to is landscape.cncf.io. By the way, any of the discussions that we have today or any resources that we share that we talk about, you will receive an email from Kirsten. She's going to send out an email with all the details that we discussed and the blog itself, which this is based on. So you don't really have to take a note of any of that. We will share all the resources. But yeah, if you need to do anything, like if you need to do messaging, if you need to pick a container runtime, there's lots of options. And the options exist because of flexibility, because
Right.
one solution might give you something and the other solution might not give you what you want. And when that happens, things start to get a bit complicated. Tennis,
Right.
what do you think?
Yeah, it's exactly. And if we could switch over to Miro, there's a pretty good depiction we can use. Let's see. Oh, I can see Miro. That's good. One thing that we can talk about is how in a monolithic world, this is my rendition of a monolithic application.
This is
You have the operating
absolutely.
system. Yeah, yeah. Excuse the crayon handwriting. I'm not a trained artist, can you tell? The app inside the jackhammer, the app had to have, in a monolithic model, you had to have all the things in it that you needed to be supported, like logging should be an ing, like logging and error recovery and metrics and database access. Lots of goodies that had to be included as a part of the application in a monolithic model. That is what we wanted to get away from. And Salman, I don't know if you wanted to add on to that, anything that.
Yeah, absolutely. So we're assuming that you might, back in the day, you're developing monolithic applications, and then everybody comes along and says, you have to include everything within the application, and that's fine. But then we need to break these applications up, right? Is that where you were going to go next? Then
That's right. That's right. Yeah.
We need to break them. Maybe I can try and sketch maybe I can extend your diagram a little bit.
Sure.
Tennis. So I mean, what we've got right now is an application that is a monolith. And what you need to do is you need to take the application and break it into microservices. So what we're going to talk about is the complications that lead to why Kubernetes becomes so complicated. Why just the steps. Now, if we say, maybe I can use a slightly different color so we can differentiate between.
Sure.
So we're going to go from here to we'll take this monolithic application and we are going to try and break this up. And let's just draw some boxes here. So we take the application and we might break it up, right? In the past, the whole application itself might be doing the front end, might be doing the back end, might be doing the API. It's basically doing everything. Is that right, Tennis? That's what we get to, right? It's basically doing everything.
Yep.
But then what we say is we are working in microservices land, and what we want to do is we want to break things up. So if in your whole monolithic application you had the UI, we'll break it up, and the UI will be one part. I hope you can see this.
It looks fine.
Yeah, and then what we say is, oh, you know what? We're gonna take another thing, and this is microservices land, right? We'll say, okay, we'll make the backend. I'm gonna call it BE as backend. So that becomes the backend now, right? Oh, that's maybe a bit too big. And maybe one more component. Let's say there's some business logic, right? And I'm gonna take that, and I'm gonna stick the business BL as business logic in there, right? So we took this one application and we broke it up into 3 separate components. And as Tennis was saying before, previously in one app, you had the logging, you had the database, you had the error recovery. Now we have a distributed system. So a distributed system, and what we need to do is consider how we do the logging, how we do the error recovery, how do we communicate amongst each other, so amongst each services. So that starts to add some complications. Tennis, is that what you're trying to get to?
Yeah.
Maybe I'll stop sharing my screen for a couple of seconds so people can see us, that we're real human beings, and then we can get back to this.
We're not just a couple of Perl scripts.
We're not just some pods running in a Kubernetes cluster. We're just real human beings.
Yeah. No, the problem that comes up, and going back to what Salman was saying, is you can containerize all of these components and you can have them do just their piece, and it works great. Small problem though. What happens when you need to coordinate among these components and you need to start putting more robust logic around them? When, for example, error recovery, one of my components dies, how do I recover it? Where is it going to live? that's when Kubernetes starts coming into the picture, because it's the overall master choreographer to take care of questions like that. Again, going back to simplified applications, now we have to build an ecosystem around those simplified applications or containerized applications that takes care of all those issues that we used to have to do internally inside a monolithic app.
Yeah, correct. So, yeah, I think that's correct. And I think maybe I'll just add a couple more things, right? You
Sure.
break this application up into smaller components instead of one massive component. You've got, I don't know, let's just take one app, right? You have four smaller components, but
Mhm.
you're not looking after one application, right? Tennis, maybe you're looking after 15 or 16 applications, and each one
Right.
of them has got four or five small parts. You might end up with like hundreds of applications, correct? Hundred of little microservices they're looking
That's
after.
right.
And then at that point we bring in the containers, because you say containers solve a lot of problems. We don't have to, you have this operating system overhead that you talked about. Maybe we can go back to the diagram now. I think
Sure.
people have seen enough of us. We probably had enough, so maybe we can go back to the diagram, break it up. Yeah. So this is the bit that Tennis was saying. You got an operating system running, but then we break this up. We don't need all this operating system, or we need to make sure that all the dependencies for the applications are included. So we containerize it. So this is where the first complexity comes in. So you're starting to add a new layer, right? So well the second, let's say. So we broke the application up, then we introduced containers. Some people might say it's not a complexity, but it's something new that you have to learn in order
That's
to
right.
run your applications, right? So
That's
you
right.
build that as containers, and now containers there. I can run a container or two, and that's fine, right? Tennis, if a container fails, I'm sure you can log into a machine and do a Docker run and start it back up, right? That's not really too much of an issue, right? But
No.
Tennis, would you be happy if you're looking after 100 containers and 20 of them failed at 2 a.m. in the morning? What would
Oh
you
no.
would you
Oh no. And
would
and the
you
first thing, I mean, being the true lazy programmer that I am, I would write some process to restart
Mhm.
everything if they die, and that comes out of the box with Kubernetes, that capability. So you have the concept of deployments, for example, and replica sets to make sure that that kind of things don't happen, that eventuality. But that is a complicating factor. No joke. So, and also, there's all kinds of parameters, literally an infinite number of combinations to set up how big your cluster is going to be, how many nodes are going to be in the cluster. We
Correct.
haven't talked about what nodes are. Can I go back to
Yeah.
the
Yeah, absolutely. Should I share my screen? And then yeah,
yeah
exactly. So as Tennis is saying that in order to manage containers, we look towards orchestrators, and Kubernetes is one of them.
yep. So you
So
have I'm going to
so
oh sorry.
let me see where you are, Tennis.
Okay, I'm over to your right.
Oh, I got you. I got you. I mean, you're all over in
Okay.
USA, but I understand what you're saying, and oh, all right, go for it.
So basically, what you have now are called nodes, which is operating system. They're called nodes, and you have superimposed on these nodes the Kubernetes infrastructure, or Kates for short. And inside of Kubernetes, you have these entities called pods, which are a collection of related containers. And I'll put a C for container.
Hmm.
And there's all kinds of fun complexity involved in this. Um, for example, the, the relationship between the nodes has to be set up with certs to make sure that they're authorized to talk to each other. Similarly, within Kates, there's certifications, there's certs set up for that, and there's all kinds of parameters to verify that the correct permissions are for the pods running on the particular nodes. It gets very involved. So I don't know, Salman, if you wanted to.
Yeah, absolutely. I'll extend what Tennis is saying. In order to run our applications in Kubernetes, we need to run it on some resources, and the resource comes in the shape of machines. So the nodes that Tennis has drawn in front of you are nodes. They could be virtual machines, they could be actual machines,
Mhm.
they could be a Raspberry Pi, they could be your little laptop, whatever it might be. So a Kubernetes cluster is made up of nodes, or called worker nodes, and another component. I think I'll use the same sketching as you did, Tennis. Oh,
That's all right.
okay, we'll go with that. I think I'm just gonna undo this, and I'll go with
Yeah, you
here you
do
go.
pretty boxes. I do
I'm
Bronco
gonna
and
do
boxes.
the boxes, right? So because that's a little bit easier for me to write. So this thing is called our control plane. So the control plane is the thing that's in charge of running. I'm gonna write CP as control plane. Control plane is the thing that's in charge of running these pods and whatever else that needs to run inside the Kubernetes cluster. Now, imagine you need to set this up yourself. So another complexity comes in from when you have to create the cluster, you have to configure all of these components inside. For example, we'll take a couple of minutes, Tennis, and explain some of the components inside Kubernetes. Do you think that's a fair thing? Because
Oh, sure, yeah.
it might give you an idea of what kind of complexity we're talking about. For example, let me just go in here in a control plane. Let's just make it a little bit bigger. There you go. In a control plane, there's the API. As the API is the one where you have to submit a request. It goes via the API, and it takes the request and stores it in etcd. Now, the request that you write is written in a YAML file. So I think this is another point that we need to talk about. Is anytime you need to create something inside a Kubernetes cluster, you have to write a configuration file. And the
Yes.
configuration file is written in YAML, and etcd stores that configuration inside the cluster as a source of truth, so it can go back, because Kubernetes is a declarative infrastructure. It knows at what time what's running. But anyway, in order to configure your cluster, we're not talking about application deployments yet. We're just talking about your cluster configuration. You have to set up etcd, which is a key value database that stores your resource definitions, definitions that you ask for. Like, I have a deployment, it needs to have this many replicas or that many replicas. Now that needs to be configured, and that has to be in a fault tolerant way. If you're managing this yourself, you have to set that up and make sure that you got enough nodes that can recover if there's a failure. Because if etcd fails and you only have one instance of etcd running, your Kubernetes cluster is dead and buried. So
That's right.
there's more components, and there's the different types of controller managers, there's different types of schedulers. Now, and certs, as Tennis was talking about, the certs. There's a lot of these components. When you're configuring, you have to set them, and these components have a lot of properties that you can set. And then you might be able, for example, I'll give you one example. There's tons of examples out there. One example is what's known as a pod eviction threshold. Now, if a node fails and the control plane doesn't get a response from the node for this given time, it will try and evict the pod from the node and move it on to the other node. Now, that is in minutes or seconds or whatever it might be. So the point is, there's some configuration that you need to be aware of, need to understand in order to set that, depending on what your application is. That's just to give you an idea. Now,
Mhm.
you set up your control plane, and as you were saying, you also have to set up your nodes. And in the nodes, there's a number of components. I think I'm just going to point to a couple of components which will show why there's a bit more complexity when you're setting up the cluster. There's a
Sure.
lot more, but we're just going to add a couple more things. One of the things in your cluster is the container runtime interface, CRI, container runtime interface. Think Docker on your machine. Think the bit that runs the container.
Mhm.
That's CRI, container runtime interface. Now, why is it not called just Docker within Kubernetes? It's not called Docker because they've created an interface, container runtime interface. Because tomorrow you say, I don't want to use Docker. I want to use, I don't know, Podman. I want to use Containerd. I want to use Cryo, whatever I want to use.
Mhm.
And now this is why people think there's perceived complexity, because you need to understand what kind of runtime you want, how to configure it. So out of the box, plain vanilla Kubernetes doesn't give you this, and that's why there's some more options for you to decide. I mean, container storage interface. So how do you map your drives onto the nodes, onto the pods? That's a whole topic in itself.
Yes.
In short, what we're trying to say, Tennis, is that configuring a cluster to run your application is not an easy task.
No.
Correct, Tennis? Because you have to
No,
go
it's
through and
yeah.
configure it, and you also have to decide the number of nodes. I think I'll stop sharing the screen for a second. You have to decide number of nodes. You have to decide what components you want to use. They're all pluggable and modifiable. Anything you want to add on that, Tennis?
Yeah, that's all absolutely accurate. And the cloud providers have tried to mitigate some of the complexity by having their own prepackaged offerings. In the case of AWS, it's EKS. In the case of Azure, it's AKS. In the case of Google, it's GKE. But basically what they do is they take on the task of managing the environment for you, with the view to having cut down on a lot of the complexity of setting it up. That is not, they are not the be all end all, however, because you're still left with plenty of complexity to worry about. But it's certainly much better than it was setting up your own cluster, which, by the way, we know a lot about as a company, because COPS, the well-known cluster orchestrator creation tool, is maintained. Well, put it this way: in the top 20 contributors of COPS, we have at least 3 of our folks, engineers, are in the top 20 contributors. So we know something about what we're talking about. Salman and I don't, but everybody else does.
Absolutely, yeah. You can, know about COPS, we can talk to you about other stuff. But absolutely, yeah. So as I know we talk about complexity, and our point is not to scare you. That it's complex. It is complex for a reason. As we, there's an example that we talked about was a runtime interface. We said, oh, why does an interface exist? Because it's pluggable. You can pick one, or you can pick the other one. Now, as Tennis says, there's options. You can go for a cloud provider solution, which is the managed service. You can go for Google, Google, AWS, Linode, whatever you want. And plus, there's some more complexity that you can use, or you can use tools like COPS, KubeSpray, KubeADM to help you configure it. But still, there's a lot of work you need to do to make sure the cluster is secure, the cluster is manageable. But we'll come to that security stuff in a little while.
And we haven't even talked about distributing your applications on the cluster and CI/CD pipelines and all those kinds of concerns.
Correct.
Which is a big concern.
Yeah. So maybe before we move on to the next bit, if you've just joined us, welcome to the webinar with myself, Salman, and Tennis from Appvia. We're talking about why is Kubernetes so complicated. The idea of this session is to give you an understanding of why perhaps some of the components can be perceived as complicated within Kubernetes. What is the reasoning behind it? Of course, we can't cover everything. We'll send a bit of a summary at the end of it. You'll get it in an email after the summary. And before we forget, we are doing this as a series of webinars. So if you have any feedback for us, feel free to reach out to us. I think you can leave a message here, and if there's any topic you'd like us to cover, you can let us know. We've got 2 more webinars coming up. Next week we can talk about at the very end. But so far, what we talked about is the complexity of taking your application, your monolithic application, and breaking into microservices. So we've got a distributed system. So you have to think about all these things, like how do I do the distributed logging? How do I do distributed fault tolerance and all that sort of stuff? And then you bring in containers, because you want to be able to incorporate all the dependencies within the container and run it. But managing container one by one is not that easy by hand. So we use a container orchestrator, and Kubernetes is one of the ones that's winning the race. I think that's a valid point to say there, Tennis.
Very much so. And we have one question that's come up, which is, what are some alternatives to Kubernetes?
Okay.
And it's an interesting. I'll go ahead, take a stab at it. I've got some ideas, and
Yeah,
whatever you
sure. I
think.
mean, yeah, there's many alternatives to Kubernetes. It depends on what your requirements are and what you're trying to do and where it is. For example, you can HashiCorp have HashiCorp Nomad. That's a Kubernetes orchestrator. You can use that to run your containers. People, if you are within AWS, you can use AWS Fargate, Elastic Container Service. You can use some of those. You can, depending on what you're trying to achieve, you can even use Docker Swarm to do your container orchestration. But it all depends on what you are trying to achieve and what your requirements are. So there are some out there. And I don't know if you want to add anything more, Tennis.
Yeah, there's a couple things. You can go the serverless route, which
Correct.
is
Yeah.
basically functions as a service, as an alternative to Kubernetes. Architecturally, a very different animal, and while it is very attractive in some ways, it's also provider specific. So if you do serverless on AWS, you will have to tailor it specifically for AWS. Similar facilities are available on the other two cloud providers. But in every case, it is proprietary. So again, everything that we've described, nothing's free. Everything's got its costs. In the case of serverless, that is the cost of serverless. And the question that came up, what are alternatives to Kubernetes? This is not to frighten you away from Kubernetes. This is a sober assessment of Kubernetes. It is not a Kubernetes and how to avoid it webinar.
Yeah.
So don't think that we're trying to talk you out of it, because we're not. We're big believers in Kubernetes, but we also are big believers in thinking professionals using it rather than people who are not walking into it without having done their homework. Anyway, I anything you want to add to that, Salman?
Yeah, I guess I resonate. What you're saying is use the right tool for the right job, and
Yes.
if you need to just run a little script that, I don't know, does something at 8 a.m. in the morning or 6 a.m. in the morning, pull some data from somewhere, functions is an excellent choice, and that's what a lot of people do. That's what I've done in a lot of places. So yeah, I mean, that's absolutely fine. If people want to know more about different container orchestrators, perhaps we can do another session and explain that.
That's right. That's right. And this, just to let everyone know, and this is a nice segue into it, is we have a couple more, as Salman alluded to, we have a couple more webinars coming up. And the one next week is when you should not use Kubernetes. So that, and we will specifically talk about those situations then.
Yeah.
And then
correct.
on the 29th, that's the number 16th, November 29th, we're going to be talking about who's really doing a good job running Kubernetes. What's does a successful implementation look like, basically?
Okay, that's fair enough. Is the answer to that Appvia? Is that right?
Yeah. And speaking,
Always
actually,
joke,
and
but
this is a good. That's fine. This is a good juncture to talk about Appvia and what we bring to the table as far as dealing with Kubernetes is concerned. We offer an enabling technology that mitigates a lot of the complexity of Kubernetes. And do you want to go over the highlights of it, Salman? Or
yeah, perhaps if we cover other complexities of Kubernetes, and then in the end we can talk about
certainly,
what does help with. What do you think? I think that might be a good idea if we just talk about what other
sure.
complexities are there. So we covered the infrastructure complexity. I think we'll probably go on for another 10-15 minutes, right? If there's any
That's
more
fine.
questions,
That's fine.
we can. So we talked about the complexity of configuring your cluster to run it. There's a lot of options there, lots of components you have to install. Also, you have to think about how do you upgrade something, because this is running on an operating system. You need to make sure that's upgraded. Any vulnerabilities that come in from Kubernetes itself, you have to upgrade Kubernetes. So there's a lot of work that you need to do in order to maintain your Kubernetes cluster. And if you take a managed service, that alleviates some of your pains. But that's only the cluster. Some issues with the cluster management. So that might be something that your DevOps people in the organization, your SRE people in the organization, the infrastructure people in the organization, they will be dealing with. What about the application developers? What about them? What kind of complexity do they have to deal with? maybe we can talk about that. Do you think that's
Certainly.
that's a good idea? Maybe should we just share a screen and maybe we can do a couple of things on there. Let me just
Yeah.
share a screen. You know, this technology, you gotta. Okay, so I've got a cluster here at the top, and I have an application that I need to submit in order to deploy an application in Kubernetes. I write a YAML file, and well, if since you can see it, so we can say Kubernetes deployment. Just to give you an example, if you've not seen one, I can show an example. So maybe let me just make it a little bit bigger.
No, that's fine.
You can see that, right? So
I
I
can see it's
write.
fine.
Excellent. So in order to deploy an application within Kubernetes, you use what's known as a deployment. And in a second, we'll draw some diagrams and explain it to you, which will explain some more complexities of why they exist within Kubernetes and what we can do about them. So what we got here is a deployment file. And there's a lot of things happening in there, but the reason why I'm showing you this file is because there's a file that's got a lot of key value pairs inside, and there's specific information about what kind of resource it is and what kind of image it's using. So this is a container image that's running, and there's some configuration in here, the ports that need to run, and some labels that you need to add. But basically, the point is, in order to deploy an application, you have to write a ton of these YAML files, and the way the application structure in Kubernetes is a bit like this. I'm going to draw some diagrams, tennis, and then we can talk about them.
Oh yeah.
Actually, let's just go down a bit more. Oh, what am I doing? Let's go here. Okay, so let's draw some diagrams, right? So what I've got is a deployment. So that's my deployment. I'm gonna write a deployment on the side. Deploy. That's our deployment. And then when we draw our deployment, in a deployment, we define how many containers we want to run, how many replicas of the application we want to run. And in our case, we might be running, let's say, 2 pods. And a pod, as Tannis was saying before, is just running a container inside one or more containers. Now, in this case, we got 1 pod, and I can also have another pod, right? Because it's part of deployment, I can have multiple replicas running. So I can have another pod. So I've got 2 pods. And inside that, it's just a normal website, right, Tannis? There's nothing special, just a normal website that's running. And the reason why we're running 2 replicas is if one fails or if there's a lot of load on it, I can distribute the load and things can go there. Now, back in the day, you run your application and you say, all right, I'm done. My application is running. You give somebody, it's like a web server, right? Let's say it's a web server. You go in, you run the Python website on there, and you can just run it, and everything's great. But in Kubernetes, what we want is to, you'll see there's a few more components that you have to deal with. And we'll talk about why they exist. So as a developer of these applications, there's some more things that you have to consider that you didn't used to before. And you might think it's a bit unfair, but hopefully we can explain why they exist, right? So we've got a pod here, and on the top, there's another component, what's called a service. So let's go service. Oh, not service. Now the service is an abstraction, layer, because I might have a pod here and a pod here. This is one application. And I might have another pod somewhere else that's running somewhere else. Let's just call it pod 2. Pod 2, that's running somewhere else. It's not part of the same deployment. It's a different deployment. Now, the pod 2 here wants to talk to this pod here, which is, I should really write the number here, pod 1. So pod 2 wants to talk to pod 1. We can get pod 2 to talk to pod 1. You can directly call things. But what happens if the pod dies? Now, how do I communicate with the pod? I need to know the IP address, I need to know the port, and all that sort of stuff. So Kubernetes says, don't worry about that information. Don't worry about what the pod IP is, what address it is, where does it exist. What you need to do is you need to call the abstraction layer, which is the service. Now, if there's these 2 pods inside, pod 1 and pod 1B, I'm going to call, right? Pod 1, pod 1B, they're replicas. How do you pick which pod to send the traffic to? Because we need to do load balancing. And that's why we've got this thing called a service. Think of service as an internal load balancer. The pod sends the request to the service, And the service, there's different types of services depending on what you want to do. There's 4 different types of services. And then the service says, okay, I might have like hundreds of replicas, or 2 replicas, or 3 replicas, whatever it might be. It'll pick one and it will send it. And it will send the response back to where it needs to come to. Now, the services exist as an abstraction for an internal load balancing. And that's why there's this extra part of configuration YAML file that you have to write in order to do that. But it doesn't end there, right? Tennis, can I add another couple of points, and then maybe we can talk a little bit more. It doesn't end there, right? You might be like, okay, am I done? But no, not really. We're just getting started. So if I can go another one. Now, the service, we said, is an internal load balancer. So the traffic there's in the service is all about running inside the cluster. What about if I need to send traffic from outside of the cluster? What if some person is, I'm gonna stop my screen for a couple of seconds, Dennis. We can go back to it. What if it's a website that some people need to access from outside the cluster? Like, I don't know.
Right.
Name your favorite website, Tennis. What's your favorite website?
Oh, I don't know. Amazon?
Oh, wrong answer there, Tennis. It should be appvia.io. That's your favorite website.
True.
So let's say we've got appvia.io running inside a Kubernetes cluster, which it is, right? And we need to make sure it's available to the public outside the cluster. And in order to do that, we use another component called Ingress. And an Ingress is the bit that allows you to route traffic from outside the cluster to inside the cluster. Think Ingress as your, like, the load balancers, like Nginx load balancers or Kong load balancer, or some one of those things. Now, Ingress by default in Kubernetes is not installed. So when you set up a cluster, you have to decide what kind of Ingress you want to use. And there's different types of Ingresses that do different things. The way they do their load balancing is different. The way they handle their sessions is different. The way they handle stickiness is different. Now, you might say, well, that's a bit complicated because I have to figure out what Ingress I want to use. How do I configure it? But now that exists just for that reason, for the extensibility of Kubernetes. So as a developer, you'll have to write an Ingress file that maps everything, right? That maps it, says, okay, make sure this is what happens. By the way, if you need a webinar on how to write all these things, we can do one, a bit of a session. But you have to map this up and say, okay, Ingress, you talk to this service. So if somebody goes to appvia.io, they end up on the Ingress, and the Ingress says, okay, if the request comes from appvia.io, you have to send it to the service. And the service goes, okay, if you get a request from this Ingress, you have to send it to this pod. It has a label, and then return back a response. Now, you configure all this stuff in configuration file like YAMLs. So there's a bit more work that you need to do. That's why it's complicated, because of extensibility. But it doesn't just stop there. What about your environment variables? What about your secrets? All of that stuff goes in configuration files. For example, your secrets. Yes. You can use Kubernetes secrets. Now, they exist because you're not going to have the same secret in every environment, right? Every environment will have a different secret, correct? Tennis, like your database connection in dev is going to be different.
Everything has its own secrets, and that's a big subject in itself, is handling secrets.
Yeah, correct. And you'll end up with an application might end up with, I don't know, 8 or 9 YAML files. Correct. And then there's a lot of, correct, right? And you might be like, oh, that's a lot of complication. And that complication is 100%. There's a lot of files you have to deal with. So I don't know if you want to add anything, Tennis.
Yeah, one thing to point out about Ingress, Ingress is interesting because it's on the the periphery of Kubernetes and the provider environment. It sits on the edge because literally it's ingress from the outside world into Kubernetes. And because of that, it is not exactly proprietary, but it does have a lot of bells and whistles that vary between the different cloud vendors. Correct. So Ingress is not quite the same on Azure that it is on AWS and, of course, on Google. There are going to be different kinds of parameters that you're going to have on each. So you have to be really cognizant of exactly how it's going to get used.
Correct. So that's absolutely right. So what do we do with all this application complexity? Well, the first thing is you kind of have to learn what these different components are, right, Tennis? You have to understand
Oh, yes.
what deployment is. You have to understand what a service is. You have to understand. I'm going to stop sharing the screen now. You have to
That's
understand
fine.
all these components, and you have to also understand. We haven't talked about a lot of things yet, like how do you do storage? How do you do stateful apps? Actually, we have a few blogs coming up quite soon. So head
Mhm.
over to Appvia blogs. You can check out these. Tennis already wrote this beautiful blog that I'm, actually, maybe I should share the screen again. I don't know why I stopped sharing the screen. Tennis wrote this great blog about why is it so complicated, the thing that we're talking about now. But of course, these things uh, are there, and they're a little bit complicated to start with. But you can understand them, you can learn them. There's some resources that we'll share with you later on, and you can read our blogs and perhaps understand a little bit more about why they're complicated. So some of the things that we really haven't touched upon. Our link actually is in the announcements. There you go. A link has been added to the announcement section. So if you head over to the announcement, you will see that there. Thank you very much, Kirsten, for sharing that. Beautiful. So what we haven't touched upon is a lot of other components in Kubernetes that are complicated. But I think Tennis, maybe I should do a bit of a recap as to how can you deal with this development complexity. You can use tools like, let's say you don't
Mhm.
want to write all these YAML files and apply them to Kubernetes cluster. There's tons of tools out there. There's Helm template, Helm that allows you to do templating. There's Customize. There's quite a few tools out there. There's also even Kubernetes API where you can use the client libraries, and you can write your YAML files as code and submit them, like Kubernetes resources code, and submit them. But there are some tools out there that allow you to package your application and deploy them. And
Yeah, yeah. Ultimately, Kubernetes is a bunch of APIs under the covers, and you can write your own tools to talk to those APIs
correct.
using a language that it understands. So there's a great deal of flexibility, and also there's a great deal of opportunity to hurt yourself if you're not careful. But there's a tremendous amount of flexibility. And by the way, one point to bring up that we touch on or have touched on with other webinars is that the price of admission for Kubernetes is growing a kind of internal priesthood in your organization that will understand Kubernetes and will typically fall into the DevOps group name under the name of DevOps. They will be the ones who will understand or be tasked with understanding Kubernetes, and it shifts the onus of understanding from classically the application people to the Kubernetes administration / DevOps people. That's a cultural shift that needs to happen as well, and also, of course, part of the complexity we're talking about.
Yeah, that's cool. So maybe if you're joining now, welcome to the webinar, and we are talking about why is Kubernetes so complex. So maybe Tennis, should I give you maybe give a 1 minute summary of what we discussed, and maybe we can start wrapping up and what the next
Yeah,
steps should be. Should we do that?
yeah,
Um,
sure.
yeah. So what we started with saying is that it starts to become a bit complicated because you have an application which was a monolith before. Everything's inside the application. You take the applications, you run it inside the virtual machine, and everything's good. But there comes a point, and you go, if the virtual machine fails, that's a bit of a problem. What do we do? So we break the monolithic application, into microservices architecture. If you need a bit of you can look at 12-factor apps to help you understand if you want to break up your applications. You can use Strangler pattern. We're going to send some links later on to help you break your applications up. Once you have that, you use containers to run them, because containers give you some features like all the dependencies are included inside in one place. You can build and you can run it. You can manage 1 or 2 containers, okay, but if you've got hundreds or tens of containers, you need to make sure if one crashes, you can bring it up. How do you scale it? And this is where Kubernetes comes in. And Kubernetes is a container orchestrator that allows you to deploy applications. And as Tennis was saying, Kubernetes is basically just one massive API that's open for extensibility. So you can first of all, you have to create your own cluster and install all the components. And we said, well, you can't do that, but it's a little bit, you basically need to know what you're doing. Or what you can do is you can use one of the managed providers, or talk to Appvia, or talk to somebody who uses Kubernetes quite a lot, and use one of the managed services. And we have a product that allows you to spin up your Kubernetes clusters in some environments and does all of that for you. Then you don't have to worry about installing some of those components yourselves. So that's infrastructure complexity. And we have the application complexity. Like, why is it so complicated? And I think we shared. Maybe I can do a quick one. I'll share the screen here again. There's different components that go into writing your application. So you have the applications that run as pods, then we have services, then we have ingresses. The first complication is that you kind of have to understand what these parts are, what to do, and how to write them, and how to deploy them in a Kubernetes cluster, and how to manage them. You can use some of the tools. So we haven't even touched upon security of the Kubernetes cluster.
True.
Out of the box, not a lot security exists. So you kind of have to look into what the network policies are, make sure the pods are that supposed to talk to each other can only talk to each other. Nobody else is talking to each other. So there's some projects that exist that help you with security of your Kubernetes clusters, and also your applications that are running inside. It scan your clusters and looks at that. So that is a summary, I think, of what we discussed. I think what Tennis's point was, yes, it's complicated, but fear not, right, Tennis? I don't know if you want to give some parting thoughts to people before we.
Sure, exactly. Don't run away. Everything is, controllable. Kubernetes, while it is a complex beast, there are ways to mitigate the complexity. We offer a product called Wayfinder that allows you to pre-configure what a cluster is going to look like in a very opinionated way, that an administrator would configure ahead of time what a cluster would look like. And then you would allow users at the time they need it to say, please give me a cluster, and the cluster will be instantiated and have all the bells and whistles and correct security hooks and things like that you have had the administrator pre-configure. And that makes the process of bringing up a cluster so much simpler than even, and this sits on top of the managed Kubernetes offerings from the big three cloud vendors. So we invite you to have a look at that product because it could help address any issues that you may have dealing with the inherent complexities of Kubernetes.
Cool. With that, we got a couple of things to say. Is first of all, thank you for joining in. We got another webinar next week, November 16th. Do you really need Kubernetes anyways? And we'll talk about some of the reasons why you should not adopt Kubernetes. We'll talk about how you should not run away from Kubernetes, like why you should not adopt Kubernetes next week. And the week after, November 29th, who's killing the Kubernetes game and what you can learn from their successes. So there's some use cases on how people are using it, and hopefully some of them will resonate with you, and some of the tips that you can take that might help you adopt Kubernetes a little bit easier, just that bit easier. But we hope that you found it useful as to why it's a bit complicated, because there's a lot of extensibility and you kind of have to learn some of that stuff. But hopefully some of the resources that we have on our website, you can find out. There's tons of resources on YouTube. You can find us on LinkedIn and Twitter if you just search for Soulman Iqbal, Soulman Iqbal on Twitter, YouTube. You'll come across my profiles. But if you have any questions, you can email us. Salman.iqbal@appvia.io, tennis.smith@appvia.io. And please do leave some feedback for us in the feedback tab. I think that's the thing that is on the right. You'll see somewhere on the right there's a feedback tab. Just please give us feedback. Yes. Tennis, anything else you'd like to add?
No, sir. I think we covered it.
Okay. On that note, we will say thank you all for joining us, and please stay tuned for the next one as well. We'll be doing a lot more of these, and let us know what you'd like to hear about. We hope that you found this useful, and wherever you are, have a good day, evening, afternoon, night. Thank you.